Okay, now for an application of gradient and of partial derivative. So the tangent plane to f of xy at the point P of x0, y0, z0 has equation z minus z0 equals fx evaluated at P times x minus x0 plus fy evaluated at P times y minus y0. So this is the equation. If I know my function, I only have to find fx and fy, and I'll have an actual equation for my tangent plane. Or if I have the gradient of this thing, right, I'll have fx, fy. If I have the gradient of my function at a point, then I automatically get for free the tangent plane. So I want to show this. So let's try and show this. So the tangent plane to f at the point x0, y0, z0, we need a point, which we have, and a perpendicular line, right, a normal. So the point we have, the normal, this is what we're trying to find. So certainly it is true that any plane tangent to f at P has to contain all lines that are tangent there. So if for example, we know two very special lines, i.e. L sub y of t, which is x0, y0, z0 plus t times 0, 1, fy, and Lx of t, which is x0, y0, z0 plus t times 1, 0, fx. Remember, these are, from the first slide, tangents. This is the tangent in the y direction. This is a tangent in the x direction. And so what we get is two vectors that must live in this plane, right? We must have a vector parallel to 0, 1, fy, and a vector parallel to 1, 0, fx. And so a perpendicular to this plane is the vector given by 0, 1, fy cross 1, 0, fx, right? If I take two vectors and I find their cross product, I get something that's perpendicular to both of them. And since I'm looking for a normal to this plane, something that's perpendicular to this plane, and I know that it contains the vectors 0, 1, fy and 1, 0, fx, then the normal will have to be their cross product. And so in this case, the normal is fx, fy, negative 1. And if I plug this into the equation for a plane, I get fx times x minus 0 plus fy times y minus y0 minus z minus z0. And this is exactly what we were trying to prove. Okay, so if you want to find the equation of the tangent plane at a point, you only have to know what fxp and fyp are. And your point, and that will give you the normal. So here's the normal to the plane that we were looking for, and the p is the point. Okay?